This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, welcome to Lecture 6, everybody. Again, my apologies for not being here last week, but I understand that Peter Shakte looked after you quite well. So last week you covered immutable objects, or objects really, that you can't change. This week we're going to be covering mutable objects, but before we do that, I just want to cover a few things first. It just pointed out to me that Lecture 5 slides weren't available. I've just made those available now, so you can access those online. A point to note that my lecture slides look slightly different to Peter's, but they are exactly the same materials. So you should see exactly the same thing, but it may look a little bit different, so you won't be missing out. I will try and find a copy of Peter's slides just to upload in any instance so that you have an exact copy for the recordings. Now, assignment 3, I want to cover that before we go on to today's subject. But before that, I want to just make a sort of a sub-announcement for later on so that you're not shocked or scared. Is that a torch up there? Is that a head torch you have on your... Anyway, it doesn't matter. I'll want to ask for 3 volunteers at the end of the lecture. So I want 3 brave souls to come forward to the front and just do a little demonstration with me. It won't hurt, it won't embarrass you. It's just a way of sort of iterating one of the subjects we will be covering today. But I'm putting that out there now so that when I do ask at the end of the lecture, everybody doesn't go like, oh, I'm really scared, which they have done in previous years. But anyway, so we'll come back to that. So assignment 3 is all about testing, right? So up until now, you have been producing work that I've asked you to produce, and then I've been testing your work to see whether it meets a certain standard or a certain criteria, and that's how it's been working. But this assignment will be where I will be providing some code, and you will be testing the code. So your job will be to unit test the code yourselves, and what I'll be looking for will be whether you find an error or not. So the key will be that you will be trying to find faults in a code that may or may not have a fault, right? So often what we do discover is that it's really difficult to write software that's really robust, and robust meaning that it doesn't break, doesn't fail. And testing is a massive part of your job. So when you become a programmer for a company or for some enterprise or for any professional aspect, testing your code becomes paramount. It becomes a very important facet of what you do. Now, often, when you test your code as the developer, you'll test your code as the developer, right? So what you're really doing is you're writing your code, and then you're doing this, praying, and you're pressing test. And if it works, you're very, very happy, but you don't test for bugs. You don't try to break the code, right? But when you become a tester, when you do work as a tester, it's actually good when you find bugs. So you try your hardest to break the code. So it's a very different hat to wear. So that's something I want you to get used to, is testing your code robustly, because it's a very important part of being a very professional programmer. So you'll do, there's kind of different types of testing. I think we started. There's different types of testing, but the majority of what you'll be doing, the script will give you information on testing robustly in a sense that you can test as you go along. You can test for every combination of or permutation of work that you have, or you can run what we're going to be doing is kind of sub-testing or testing software that actually tests the main code. Anyway, so if you have any questions on this, do come and speak to me. But I think you have until the 13th of September to complete the task. If The server, I'm not sure how well the server's working because we had issues on assessment 2. I will have that double checked this week. Obviously, I've been away over the past week and I've only returned today. So I will be able to test the servers really well for you over the next sort of few days. But if you do experience any problems, don't hesitate to let me know. So with that, we'll review quickly what we did last week. And the reason I'm reviewing what we did last week is because I wanted to give you some coding examples so that you can see essentially some of the things, how I feel, what I think you should be able to understand and do. Oh, hang on. So what I'm going to do is I'm going to fire up NetBeans and give you a quick example on objects, creating new objects, constructors, the accessors and getters. And this is going to be a very quick overview, so don't think I'll be taxing or labouring this for a very long time. I want to sort of get you into the understanding of this protocol, the way it's actually implemented, the toString, and then sending data, and also copying new objects. So essentially what I have here is I've created a new person class. So you all know how to create classes now. So this is just, as you would expect, a class called person. We're going to call this an object. Okay, so this is going to be an object, and that object represents anything you want it to represent, but in this case it's going to be representing a person. And the basic construct of this object will be that the person, for this example, very quickly, will simply have a first name and a last name, right? So because we were doing immutable objects, the way to make an immutable object is to essentially have the object that cannot be changed. And if you remember, you'd have oh my gosh, you'd have the private construct, and then the final, which is saying we don't want to change this object, and then you give it the type. So this type is going to be string, and then the value, in this case, let's just say first name. And this is going to be essentially the first parameter of our object. The second one will be the same thing. Which will be the last name. And you can see that these are having issues. They have errors, and I'm assuming, just double checking, that the error is just pointing to the fact that they're not being initialized. So one of the features of the keyword final, it's making any object immutable. Now we know strings are immutable anyway, but you can do this to any object as well. But the keyword final simply says, look, you're not going to be able to change this when I create the object. If you remember the new keyword, the new object, you're making a new version of that object in memory that you can utilize as you need to. So the way to do this in this instance, because we're making this be final, and we're not making it static, so we're moving away from the static. If you remember, static was the week before, where we had to use static objects and static variables. Now we're moving away from that, and we're instantiating the objects and the variables. So last week you would have learnt about the constructor. And the key I want to point out about the constructor is simply that it has to be public, and it has to be named after the class. So in this case, the class is called person. So public person will be the constructor, and you know it's a constructor because it doesn't have a return type. So when you make a method in Java normally, you would have a return type here, right? You'd have either void or something like that, right? But we're not having that, we're removing that, and that by definition, it's named after the same name as the class, and it has no return type, defines it as a constructor. Make sense? So for now, I'm going to have, a no argument constructor, so there's going to be no arguments. And then we're going to just define first name. Now, this keyword, because when we instantiate this object, when we create a person, like a theoretical person, we're going to create an instance, a version of that person. We can have millions of versions of the people. We can have tons of people everywhere. But in this case, each person has to have this constructor run. And because that instance, if you can imagine in your mind, when I'm creating a copy of a person, that instance of that person becomes that person, or shall we say this person, right? So we use the keyword this to refer to this variable here. So these are part of the object's values, and when I use the keyword this, I'm talking about the actual variables that exist for that instance, okay? So this, and then it gives me we're going to say first name is equal to, and actually I will put parameters here. Oh my gosh, person. I'll put string name and string, what did I say it was called, last name. Right, so now I have two strings that I'm passing into the constructor, and oh dear, I'm all butterfingers here. There you are. So essentially, that completes a very, very, very basic two-parameter object of type person. Very simple. Essentially, last week we covered the fact that if you don't have this constructor, then Java will give you a free constructor with no parameters, which is fine. But what this is doing is creating a person that allows you to pass parameters into that person, and those parameters are final once it's created. So that on initialization or instantiating this object, these variables here are generated by the values that you provide to the constructor on creation time, right? You can see it's complaining, saying that they're not being used because they're not. And the other thing that you covered was the toString. If you remember, you have public string, toString. And the toString is a method that every single object has. So every object you create, whether you define it or not, has a toString. So if you don't define it, when you call the toString, or when you call the object and ask to display the object, it will give you this sort of randomized memory, it's not memory location, but kind of like a randomized object ID that it holds in memory for it. But if you override, if you remember the keyword override, which we will cover more later, if you override with this keyword here, it simply overrides. So it overrides the toStrings automated version, if you will. So this is, you're giving it, so what I'm going to do in this case is simply return, just to make this complete, and then we're just going to say, I won't do that. I'll just do it like a normal, first name, and last name. Okay, so far, I'm hoping that kind of gives you a hands-on physical understanding of the overview of what you covered last week, I think. Any questions on this from last week and from this now? I'd be happy to answer them now. No? Okay. The other thing which you covered last week was a construct called the accessor, right? So right now, the only way to access this object is to call the object by name. So let me show you how that works. So I'll go to the main program here, and we'll say public voids, public static, I won't do it now, public static void main, and then I'm going to make a new object called person. Person1 equals new person. It's providing two null. You covered null last week as well, which basically says, look, I'm not giving you any information. But I'm just going to put in the parameters Bob and Smith. So now I'm creating a person called Bob and Smith. And if I output person1 and I run this, I think it's done, you can see it simply returns Bob Smith. Now, what that is doing, I'm simply printing out P1, which is the object of type person. And we created a new object and provided the input parameters of Bob Smith, right? So if I come back here, and I look at this override, if I said, if you can add more to this, you can say, my name is, and then we can run that, and you can see now it'll differentiate to you that it is indeed the object that's calling the toString, right? So that my name is Bob Smith is actually coming from the object here, this toString. But I'm not calling the toString, I'm simply calling the object, right? Now if I removed that, let me just pull this away, hopefully it gives a good example, and you run it again, you can see now it's giving lecture 6 person and some junk, right? It doesn't mean anything, but toString is still there. So the toString method is still there, but this is the output, which is kind of good for no one really, unless you're Java. So this is why we actually override the toString, so that we have some useful information for us to work with. Make sense? Any questions? No? Too easy? Okay. So we covered objects, new objects, constructors. The next thing to consider is, the only way I was getting that information was with this, but we have this thing called the accessor. And the accessor is often called a getter. And by only providing a getter, as opposed to also providing something else called a setter, which is called a mutator, which we will cover today, it gives you control over the information that you return back to the calling or to the object, the instantiated object. So what you would normally do, getters usually are public, and they normally return the type of data that is expected. So in this case, it's a string. So you're going to public string, and then what we're going to say is we're going to say get, and then you say first name, and we give it camel case, if you remember camel case, first name. And you don't supply any parameters, but you do have to return some value, and obviously the return value, but we'll go into more of this in a moment, would be the first name, but the object's first name, right? And you do exactly the same thing with the last name. Like so. And of course, it doesn't stop there. Last name. And it doesn't really stop there. You could also say just get name. So you can create these as much as you want. And of course, get name would just return what we already have, I guess. Something like that. Does that make sense? Oh, hang on, I'm trying to make this smaller. Haha. There we are. Right. So that essentially covers a demonstration of last week's lecture. Any questions on that? Yes?
So, from my point of view, I have like get name and toStrings doing the same thing. Right?
You're right. So get name, yes, you're right. Absolutely right. So get name in this instance, toString is doing the same thing as get name.
Is there any cases that there's something that toString can do, but you cannot having other methods?
Yeah, so the difference with toString, and let me show you an example to hopefully make it more understandable. So I just called P1 like this, which I'm calling the object by name. I provided the variables, but you can provide any values you want, any formatting you want, or any information you want in the toString. But the key is that I'm simply providing the name of the variable of that class, right, that object that I created. So the difference is that if I make another one and I call P1 and then I press the dot key, it now gives me the get name, which is distinctly different. So I can call that method within the object, right? The difference is that you don't have to call a method for toString. It's inherent. It's built in. You don't have to. So, but if you don't define it, you will get junk. Do you see what I'm saying? Normally, I mean, I'm using getName here. This probably not the best example because they're very similar, as you pointed out for sure. They are very, very similar. But in general, the toString in general, you would generally give some, rather than saying my name is this and my name is that, you would give information pertaining to the object that specific to your project, right? As an example, this is just showing that the toString will return a string. How that string looks is entirely up to you. And whether, say, for example, if I was to give the object some other parameters, so if I was to say private final, and we were to say double, make it an int, int age, suddenly this dot age equals age, and then add the int age here. So suddenly I've got more information now about the object. The object has more, and what you might do is you might add that to here and say age, if that makes sense. So now, as the object grows, getName just gets the name, but the toString might give you more information about everything the object has. Does that make sense? And of course, you could do the same. You could say getInfo, and you could put anything you wanted and call the method explicitly. But the difference is, you don't have to know the method. You don't have to know the method name to call the toString. You just call the object, and the object will give you the toString. So that gives you control to just call any object its toString without having to know what the method is called. So if one of your friends has built a project and he's given you the project, and you just want to see what that object that he's given you is, you don't have to know whether he's got a getName or anything else. You can just say, show me the object, and it gives you whatever value he's provided, or she has provided. Yeah? Make sense? Yes? You mean, if I understand you, do you mean like to return getName? I'm not sure I understand the question, but you can call other methods if that's what you're asking from the toString, sure. Is that what you're asking? No?
Maybe we can only change the first name and space and add the last name to the getName. To the getName method in the toString method.
I think he's saying that you can repeat the toString because toString is only based on the getName and adding the age, right? Can we return getName plus block and then age?
Sure. Yes. Yes. Was that what you mean? Yes. Yes. So I could, of course. So getName, by definition, because getName is returning a string, it is actually a string, right? I'm not sure if this will work, but like this. Oh. Right? Is this what you mean? Yes, you can. Yeah, absolutely. Because any method that you create becomes the product of its return value. So Java sees a string, even though it has a method and lots of values and lots of commands. The truth is, the return value is the product of that method. So yes, you can use that as a string. Yep. Make sense? Excellent. Yes. Right, okay, you don't have to, no, you don't have to, but it is recommended because, as I'll show you today, when this is called an accessor or a getter, right? So what I've created here is an immutable object, so we can't change it. When you create the object, it's fixed, that's the object, okay? So you can't change that object. We're going to be covering mutable objects today, so we'll be going through how to change them and using what are called mutators, and then you'll see that it's more dynamic. So hold that question until the end of this lecture, and if you still have that question, throw it back at me, and I'll hopefully try and resolve that. Okay, any questions before we move on? Okay. So this was just going over the this construct, which we've just covered. I just put a few slides from last week just to make sure that we were covering everything. Something to remember that strings, because their objects are immutable, primitive types are also immutable. So if you can't change a primitive type, you can, when we use them, they feel like they're mutable in the sense that when you're utilizing a string or an integer, you feel like you can change it. But the reality of what's happening in the background, and we'll cover that in more detail today, you can't. So immutable objects cannot be altered in runtime, but they can be changed by the nature of Java. But we'll go into that in detail. I've shown the final keywords, so I was just showing the example here of using final. You don't have to use final because it's private anyway, but final ensures that you are instantiating those values on the construction of that object. So by putting the final keyword there, you're basically saying, look, we want to know this before we begin. So we want to know this information before you begin. And of course, you can also give values to the final here without bringing them to this point, but of course you wouldn't want to set someone's name permanently as, you call everyone Bob, and then everyone who uses the object is just called Bob, which would be less useful. Okay. Where are we? Oops. Okay, so unless you have other questions, we'll move on to mutable objects. So mutable objects are essentially normal objects. They're kind of what you will use every single day, right? So mutable objects are, in fact, what you will normally create all the time. But you must consider, every time you create an object, you have to consider whether you should make it immutable. So, excuse me. So creating an object, when you do devise or develop an object, you need to ask yourself, do I want to modify this object? And if you don't explicitly need to modify the object, then make as much of that object as you can immutable. And that we'll go into the security aspects of that later on, but that protects your data so that it can't be modified from outside. Hopefully this week's assignment kind of teaches you a little bit of how you can manipulate methods from outside of an application. So Java, in its very nature, allows you to modify other people's code from the outside using handles or publicly available methods, which hopefully you learn to sort of close down as you develop code. Essentially, any instance variable that you don't declare as final here can then be modified, even if it's private. So I'll call it public for now. Wow, that's really loud. Ooh. We'll call it public for now. And we won't say final, and we won't say static, but instead we'll just give it a value, string, and let's just say some string value. Favorite color, so fav col. Okay. So this particular variable now, because it's not declared as final, it can be modified. By the end of this lecture, you'll understand. But you don't want to be able to modify something unless it's needed for the particular purpose of your code. Now, if you're writing code, like, say, for example, if you're writing something like code that just does something for you and has no particular importance, for example, particle systems, and you're making, little sparks fly out of something, it doesn't matter if somebody modifies one of those values because nobody will care. But if you're making code that you need to know something very important for a bank or for an organization, and of course, not declaring something final or making it mutable when it shouldn't be might be a dangerous thing to do. To understand why we worry about this, we need to look at the differences between objects and primitive types. So we won't be going into too much detail on memory, but this is a very like an overview sort of understanding of how memory is managed. So memory generally is managed into chunks with memory locations, and you access this term called bytes. Now in Java we don't actually manipulate bits, but we do manipulate bytes. And when you use a short or an int, you don't have to define the number of bytes or bits, excuse me, the bytes, sorry, as you would in C or something. Instead, you just simply use the int or the short or the double. And what Java does is it allocates the correct space for that value in memory. And it gives it a memory location, almost kind of like a pointer. But again, Java being Java, you don't have to worry about pointers. So you don't have to free memory, you don't have to memory allocate, you simply utilize it. But understanding how it works is very important, because I'll show you in a moment a construct of sort of memory leaks that you can have with objects which needs to be protected. So essentially, say if you have two values in this sort of example here, you have these different values. So 5 will be stored in this little chunk of memory, and 10 will be stored in this little chunk of memory. But an object would be stored in much the same way, but it uses a thing called a pointer. So it doesn't know how big the string will be. It doesn't know how big the object will be. So what Java does is it allocates the beginning or the very first point in memory in which that object will start, and then provides that as a pointer to the variable name, right? So essentially, in this example here, the value for Bo Peep, for example, is actually stored in 7192. But the pointer for Bo Peep is here, 7192, you see. So essentially, Bo Peep is a string, so a string is an object, and therefore an object has a pointer that points to the first location in memory in which that object will be stored, right? And essentially, I'll refer to both reference and pointers generically. But you don't have to specify the pointers as you would in C. If you were learning C programming, you'd have to know about pointers and you'd have to know about memory allocation. We don't have to know that for Java. However, you do have to understand that an object is stored as a reference to its location, just like a pointer. And that's important for when you start manipulating or passing values back to other objects. Because if you do it incorrectly, which we'll go through, it means that other objects can manipulate your object without consent, which hopefully by the end of this lecture it will make sense. So instead of talking about memory like this, instead I'm going to talk about objects in this sort of abstract form. So in this particular instance here, this square is representing an object, and the first value is the age, and the second value is the name. So we have Bo Peep, that's 5 years old. And in memory, that's how it would store it. So it would have the primitive type would be stored where the primitive where it is, just because it's a primitive type. But the object would actually store a pointer, which points to the beginning of the object's contents. Does that make sense? So if you hold a variable, like example here, foo, the foo will point to the beginning of the object's sort of location. The value 5 obviously will be where it starts, and then the value for the object within that object, which is a string, will be a pointer to Bo Peep, or a reference to that. And that will play a vital role in the security of your code, as we will go through. So here's an example of a person. So you're creating an int age, you're creating a string of name, and you're saying this age is equal to age and this name is equal to name. So it's just generally what we've just created. Note that these are not final. The toString is just returning the age and the name. And then you're creating a new object called foo, which is providing the value 5 Bo Peep. So that's basically essentially is producing this here. Does that make sense? Any questions on the code there? No? Okay. So if the object is immutable, like a string, the only way to make a new string is to make a new string. The keyword new is quite important. So you have a person, foo, a type of object called of person, which we're calling foo. You're providing the age of 5 and the name of Bo Peep. And then if you want to make a new version of that, you simply, of foo, if you want to change foo to be a new value, you make a new person with a value 3, Sean Seep, right? So what actually happens is you simply repoint foo to a new location with a new value, and this becomes the contents of foo, right? So foo is your variable name. And Bo Peep is then not accessible, right? So we can't access Bo Peep. Now, if you wanted to remember who Bo Peep was, or if you wanted to keep that information, then you'd have to explicitly store that information before you change it, okay? So you, essentially, if you want to keep some kind of log of your users' activities and you want to know when they're deleting things, you have to store that information if you're changing the object's values or creating a new object. Now, Java, as you know, has a function called the garbage collector. And the garbage collector simply goes around collecting any information that becomes non-accessible. It has its pros. The pro is that you don't have to think about freeing memory, so you don't have to free memory when you don't use it, and Java will just do that for you. The negative, or the cons, which I've found in some projects that I've been working on, is that it just does it whenever it wants. So you could be in a very, very high-intensity application, running everything, all the guns and all the bells and whistles, and then you'll have the little cleaner just going like, coming through, and it will basically do garbage collection, and it's a pain in the butt, to be honest, and I had some problems with that, where I had to call the garbage collector before running high-intensity functions, just to ensure that didn't happen. But it can basically make your code jutter, like stutter, which you know. So it's brilliant because you don't have to worry about it, but it's not brilliant because it does it whenever it wants to, which is annoying. But you don't have to worry about it for anything that we do for this module. We're not going to be doing high intensity calculations, so you don't have to worry about any of that. So we've looked at getters or accessors, and now we're going to look at mutators. Mutators are often called setters, so you get information and you set information. And a mutator provides information to alter your code, right? So if we go back to our example, we've got this example here. As you can see, first of all, just to explain, you don't provide a return for a mutator. A mutator simply changes the value, so the return value is void. And you use the keyword set. Now, I want to be very clear. The get and set accessors and mutators are an agreement between all programmers that that's what we will use. You can call it anything you like, right? You can call it laser pen if you want, but it doesn't change what it does. But if you want your professional colleagues to respect your work, then the correct thing to do would be to call it a getter and a setter by convention. Okay, so here we've got the variable age, and we're going to be setting the variable age. So let's pretend when you created the object, you put in the wrong age. Mostly you'd be working out the age with the date of birth anyway, but let's just say for argument's sake you wanted to change the age. You would, by convention, not by code, not by syntax, and not by, it wouldn't cause an error, but by just convention, you will use the word set and the name of the variable as a way to set that variable. And then you provide the correct type and internal variable for that. So I'm going to show you something here. Now, if I was to say public, void, because we're not going to be returning, and we say set age, and we want some value, so age is an integer, so we're going to say int, and we're just going to call that age as well. Oops. So this is now a mutator method, and it does something, right? So it doesn't return something, whereas this was an accessor, it returns something. This is a mutator, it doesn't return anything, but you provide it with something, right? And then we're going to say this dot age, and I am expecting an error, equals age. Okay, so it's giving an error. Can anyone point out why it's giving an error for this? Sorry, shout. Final, right? Because age was an example of last week's immutable object. Now, we're now going to be covering mutable objects, so we can't be using the keyword final if you want to mutate or change that value, right? So the way to simply overcome that is to allow age to become changeable. Straightforward, right? Pretty straightforward. So that now works, and that's true of both first name and last name. So you can't have final values if you want to change them later. But again, get it in your minds that if you write code, always think about keeping things final, always think about keeping things immutable, and change them to be mutable when you realize, I do need them to change. And that way you add a level of protection to your code. As again, it will become clearer as we go along. Now, what I'm going to do is I'm going to have a quick break because it's just hit 3 o'clock. So we'll have a 5-minute break and we'll continue. And we will develop that concept of mutators further. Okay, 5-minute break.
Yeah, just verifying the pointer. So if we have an object in A, and that A doesn't have a pointer, but that one, the A will point you to the current pointer of the value stored in the object, and then the pointer will point to the actual value stored by the object A. Is that what we understand?
I'm not sure, but as we develop in the lecture, we're going to be going over those pointers in more detail and showing you. We'll show you the sort of how it can cause a problem and how it can be resolved, and hopefully that clarifies the
Because
question.
I don't really understand what is pointer doing here.
Okay, so that will become clear actually throughout the lecture, and if it doesn't, come and see me. It will though, I'm sure it will.
Yeah.
You said there's going to be an error message if you're using this, like if this age equals to age, but there, when you assign age to, when you assign new value of age to the final variable age, right? But there's not an error message appearing when you assign those two final, first name and last name to those two variables.
No. Okay. I'll raise that to the class. Let me make a note of it because that's a very good point. And I'll tell you now, though, it's because you can only do that during construction. So you have to do that within a constructor. So it's a very good point. So I'll raise that in the class now when we start that. So the reason for that is that if you give the values in the constructor, it's okay. But if you try and give the values, so if it was in here, it's cool. But if you try and do a new method,
it's not a constructor.
It's not cool. Okay. So that's the reason. So good point. I'll raise that later. Yeah, thank you.
And this now applies on the reviewing the class. Should I pay more attention on like practicing coding or like memorizing the things called in the class?
I'm not understanding the question.
Should I pay more use more time?
Focus.
Yeah,
So should you focus more on
like practicing.
for sure.
program
Yeah.
Or like memorizing the things.
Oh no. Practice every time. Practice. You'll become great if you practice. If you try and memorize, you'll forget it all. You've got to practice.
So because I'm worried about the final exam is more about like the knowledge in the class or understanding the code.
Right, but the way for it to sit in your mind and to stay there and be there forever is to practice. Because if you don't, it doesn't matter how much you do. Yeah, you'll forget like this. So practice. That's my number one recommendation.
Also, you say on the document that the tracker class will be provided.
And it's not there, right?
Right.
Right. I will provide that by tomorrow. I think there were some issues, like I said, I've been away. And in fact, I had the flu. I had the flu last. I know anyway, long story short, I will make sure that's there by tomorrow. And I say that because I know once I leave this class later, I've got meetings I have to go through in the afternoon, so I may not get the opportunity tonight. If I can, I will, but if I can't, it will be there by tomorrow. But yes, thank you for raising that as well. Yes, thank you.
And for the scanner class, when we create a new object, for example keyboard, we need to type in new and blank and scanner system in.
Yes.
What does the system in do?
So that represents the standard keyboard. You can change it to the system in from, for example, data stream. So you can change the in to be instead of a system in, it can be some bytecode or some other information, or you can change that value to be different things depending on the inputs. Right?
I don't quite get that.
Okay, we probably won't be covering the depth of that, but if you just look up system.in, Google system.in, you'll see that is just the standard input, basic input of the keyboard. But you can bring inputs from other things as well, because it's very bad. The scanner is not just the keyboard. The scanner can bring information in
from the file.
Files, yeah.
Also, the system in is actually a class or?
It's a package. Yes.
Oh.
Yeah. So it's a package that allows you to bring information in from the keyboard. So in the past you'd have to do it yourself, but now since I think it was Java 3 or 4, we're on 7, 8 now, whatever it is. You have to do the scanner class yourself. You have to create your own. But they bring those libraries in and it allows a little bit more ease of the product. Yeah, exactly. Okay, thank you.
About the two screen, you write something about add override. Or do we have to do that?
It's not compulsory. I think most Java will run without that, but it's recommended. So when we go, we will be talking about this in future lectures in more detail. So we'll be doing overloading and overriding. But for now, just just memorize it for now. So if you're overriding any method from other objects, then just put the override there as a symbol that it's overriding, so that you know that you're overriding. If you try and write override when you're not overriding, it will give an error. But I think if you don't write override when you are overriding, I think it may let you off. I'll have to test with the newest version of Java, but I think it doesn't try.
Okay, I'll try.
Yeah. Okay. Okay, guys. Right. So going back onto mutators. Oh, you can't see that. There we are. Okay. So as I mentioned, a mutator is a way of setting information once the object has been created, right? So once you've created an object, a mutator is basically a method that allows you to provide more information to the object to change the values within that object. As I've given examples with the age in the one that I've given you, it basically changes that value of age on the fly. So how we would do that, so this is the object we've been looking at, and how you would change that object would be to call the object. So we've got the variable object called P1, so you call P1, and then you do dot, and then you do set. And as you can see, it's now got set age, and you can give a new value of 50. So if I quickly move that to be after this to show the example more correctly, and I run this now, you can see, oh, it's saying Bob Smith. Hello. Oh, there you go. So get name plus did we have a get age? I forget. Oh, P1 dot. We don't have a get age, so let's make a get age quickly. Public age is an int. Public int get age. You don't need a value, and then you simply return this age. Right, so I've made an accessor. Save that, go back here. So now P1 dot get age is now there. So I can now run that, and you can see, oops, is that on the screen? So the original value was 45. I printed out I called the toString of that original value. Then I mutated the value using the set age. Then I called the value with the new age. In fact, we could have just done P1 as well. Right? So we could have just said P1 here as well, which would have done the same sort of thing. And you can see it's calling the toString, right? So far, so good. So mutate is very simple. Access is very simple. Now, it's not showing. Aha. Okay. So a mutator. I mean, it says it gives a second way to change the object referred to by foo or to mutate it. But the reality is maybe you don't want to define the age in the constructor. Maybe you don't want to give the age at that point. Maybe you don't know the age. And in which case, you could create a second, a second constructor. Now, the thing to mention about constructors is you can create as many of them as you like, as long as the signature, if you remember the signature from 2 weeks ago, is different. So if I was to say public, oh my gosh, person, first name, and is that what we called it? Second or last name? Right? Oh, yep, I see it. So we have this constructor now, and we'll just copy this information. Oops. Name that one. Okay. So now you can see that I have two constructors. One has just got the name, and the second one has got the name and the age. And Java will utilize or use whichever constructor that you provide the signature for. So if I just give the names, the two names, it will use the first one. If I give the names and the age, it will use the second one. But a key to remember, when creating an object, it only calls the constructor once. So you can't call the constructor more than once for that instantiation. That means that when you're creating an object, one object, you call the constructor once. But if you're creating 1,000 objects, then you call each of those objects, each of those constructors for each object once, right? So you can call it many, many times with each object you create, but you can only call it once for each one creation. I'm not sure if that makes sense. Any questions on that riddle that I just gave you? Because it did sound like a riddle. Does that make sense? Yes.
For example, if I create an object with the first person,
Yep.
with only first name and last name, and then I want
Yeah, so if you did that, if you called the very first constructor during creation, and then you wanted to call the age would have null, so it would be no value, because, or sometimes if it's an integer, Java will give 0 as the value. But if you want to then create the age, you just call the set age, which is further down, right? So you can do that. You can call any constructor you want. But if you wanted to set the age after, you would then have to call this value here. So let me just give a quick example. Let's make a second person. So let's say person P2 is equal to a new person. And this person is going to be Sue Jones. Oops. Now, I've used the word Jones just because it's a very common surname from where I come from, which is Wales. So if I then say, did we have the age? So if I then call the constructor, so if I say system.out and call P2, what we're going to get is the name, the first name, the second name, and the age, right? So if I run that, I'm hoping it doesn't crash. I'm expecting, there you go. So it's given as 0, as I mentioned. So it's defaulted. The integer of the age is defaulted to 0 because I didn't define it. But if I call P2, as you'd expect, and say set age to some value, 1,000, I'll say 102, like so, oops, and run that with an output, as you'd expect, it then gives the new value. So you can do it either way, right? So if you don't know the value at first, you can just define. And of course, these are variables, right? You're creating these variables. These are methods as well that you're creating. So these are all things that are programmer developed. They're not keywords. Set age isn't a keyword. Set isn't a keyword. These are just variables that we agree as a collective to utilize. So the set keyword is an agreement that we all use. And sometimes they do change depending on the need. So, as the example here is just showcasing exactly what I just did. So it's changing the value, giving the value 5, then changing it, and then when you call it, it would give the output. So the question is then, why are we discussing this? You know, I was mentioning pointers. You know, what about pointers? What has this got to do with pointers? All I'm doing is naming a variable, defining methods in that variable, or the object variable method, and giving values, right? There's no pointers. Here's the thing. What happens if I then if I run this code? This is called an alias. So I created an object called type person called foo. I give the value of 5, sorry, and then the name of Bo Peep. And then I say a new person, or I create another person of type bar called bar. So now I've got a person called foo and a person called bar, but bar is equal to foo. In your mind, now foo bar sometimes throws people, but imagine that foo is person 1 and bar is person 2. So now I'm saying person 2 is equal to person 1. Now this is where it gets interesting, because at this point, when I change foo.setAge 6, I'm changing exactly the same data, the same location in memory, the same values as is of foo. So in this case, foo becomes 6 and bar becomes 6, right? So that can become a problem, especially if you haven't noticed that you've developed that construct. Sometimes it's useful, but most of the time it's a mistake and you don't realize it. So this is called aliasing, or kind of showing that the pointer, bar, is pointing to exactly the same location as foo, and foo is pointing to the same location as bar. And if you change one of them, or mutate one of those values, it changes the same value for the other. So that's very important. So let's get your electronic devices out, and let's do a quick poll. So, oops, let me just go to a quick poll here, log in. So here's a question. So if you could go on to, do you remember the username? No? So I'll give you the username up here. So it's, the quickest one is bit.ly /T Christie. Do you remember that? So if you go to bit.ly, bit.ly T Christie, with your phones, with your iPads, with your Android devices, your Apple devices, your laptops, anything that you have that can access the internet, and answer the question, which is, oops, try and get that out of the way. Haha, there you are. So, what does this print? So you've got public static void main, person foo, new person 5, bo peep, person bar equals foo, set age to 6, system.out print bar age. I kind of already told you the answer, haven't I? Kind of. So what is it going to print? It's a little homer. Has everyone got their answers? Anyone need longer time? No? Let's have a look. Aha. So the majority said B, and I can confirm that it is B. So it's 6, and the reason it's 6 is, as I mentioned before, when you define foo as a person, new person, makes a new object, but then when you define bar and make it equal to foo, it's pointing at the same object. So whether you change foo or whether you change bar, it's the same thing. You're changing the very same values. It's almost like having a static, if you will, or a static object, kind of. Use that very loosely. It's not quite what it's doing, but it's kind of the same principle. Okay, let's try another one. Let's try this one. Hang on, let me just reset this. New poll. Okay, so let's try this one. So what would happen in this instance? What does this print? Static void main, int foo equals 5, int bar equals foo equals 6, system.out print ln bar. Cast your votes. Is everyone done? Do you need more time? Anyone need more time? No one needs more time. Okay, let's have a look. I've got a feeling I know what's going to come up. Yes. So, yeah, that is kind of expected. But yeah, E is correct. No. So the answer is yes, it's 5. Because foo and bar are primitive types, not objects, right? So they're not creating new versions, they're not pointing. If you recall, if you have a primitive type, you're not using a pointer, you're pointing at the location of that value. So in this case, it's not the same as having a pointer to an object. So if it's a primitive type, you change the value. If it's not, it actually doesn't. Oops. Hope that makes sense. So then let's look at the concept of class invariance. So often I'm always sort of pushing the concept of declaring variables private, and you need to get into that sort of mantra. Always declare everything private. We'll go into the other types of declarative means later in later lectures, but for now, make everything private unless it needs to be public. And this basically protects the values within your objects so that they can't be altered after. So So we need to make sure we have this construct of when you run a method and you want to protect the values therein, you act like gatekeepers. So the idea is that instead of just changing them, instead of doing this, oh, hang on. Now what we could do is we could just go, hey, I want to int number equals 1, and then anywhere in the code, I can just change number equals 10, and so on. Oh, what is it? Oh, because it's not static. Static int. So you could just put variables into your code and not put public or private or anything like that. And you could change those anytime you want. But that is not the optimal way of doing it, because you can't put any... Oh, sorry, that's getting in the way. You can't put any conditions on that. So let's say this was... again, we'll call it age. I'll call it age 1 or age 2 because it's the second variable. And let's set age. We can call it age. So let's call it age. Now, I can now make the age minus 10, if you see what I mean. So by having just the variable and allowing anyone to change that value just like this without any conditions, without any sort of conditions placed upon that change or the mutator, it means that you can put in values that don't really correlate to the information that you're storing. So in this case, the age having it at minus 10 wouldn't be appropriate really, especially because I haven't met anyone at a negative value. So, oh my gosh. So the way it's normally done is that when you're creating any object, you put in conditions to ensure that certain values are met, like an assertion. So you can assert that a condition or a certain value is provided during the construct of that object. And that's kind of the reason we use methods. We use methods as a means to filter and to control and to funnel information so that that information is exactly the type of information that you need. And your job as a programmer will be to develop those steering mechanisms to ensure that your code is doing exactly what needs to be done, right? So here we have a missing persons class or object, which allows you to utilize the person class. In fact, we can do just that. And let's just make make that same thing for ourselves. So we'll go here, make a new class, and we'll call it missing person. And this will have. So now I'm creating a new object, and I'm going to provide parameters for that object. And this new object is going to hold other objects, right? So the new object this is going to have is a person called, a type called person, which we're calling the seeker, a type called person, which we're calling the sort, and then we're also having a location, so we're having a string location, right? So what I've created here, by doing what I've just done, essentially that is, believe it or not, an object of 3 parameters. You can't do anything with it. You could create an instance of it, but then you can't manipulate it. You could alter these because they're public, so we'll call them private. Oh my gosh. So we'll call these private. Oh my gosh. There you go. So now they're private. As you can see, they're not static. They're not final. So we can mutate them, right? We can change them, but they're private. And by making them private, we're making them, at the moment, immutable. So regardless of whether they're final or not, by definition, you can't change those because you can't see them. The only thing that can change them is this very object. So this object called missing person is the only entity that can change these values, and that gives you control. So that's pretty much the nuts and bolts of the entirety of the object. I like to think of objects as that. An object is, in fact, the contents of its literals. So this is the object right there. And everything else we do is there to enable us to control those values, right? So the first thing we need is a constructor of missing person. Can anyone tell me what the first thing I need to type in is? Public? What's the return type? What was that? There's no return type, right? So we want missing person. And now I've created an entity constructor, but we want to provide values. So we're going to have a person. We'll call it seeker. We're going to have a location, which is a string. And we're going to have a person of type, what was it, sort. Okay? So what we have now is created a constructor that takes in all the parameters that are required for the object to be generated. And I won't type all this in. I just wanted to showcase to you the basics of creating a new object and how easy it is. So what we have here is that it's actually checking first to see if the values that we have provided. Now, person, if you remember, person is an object, right? We've already created the object person here, and person has get last name, get name, etc. And what it's saying is, look, seeker, it's taking in, this is expecting an object called person of type person. So it's behaving upon this word seeker, this variable seeker, as if it is a person object. Therefore, it has all the methods and variables that the type object person has. So it's checking if the get name is empty, and it's or. If you remember, this is the or construct. And it's also checking if the location is empty. So it's looking for null values or zero values on those. And if that's the case, it's simply giving an error message, in this case, missing name stroke location, and it's then causing the application to exit. If you remember system.exit, 0 or 1, those values are just arbitrary for whatever you want them to be. This is not the perfect way to give an error, by the way. We will be exploring errors in a later lecture, but for now, for the purpose of this example, this allows us to sort of just simply funnel or control or steer the information coming into the constructor. So what we're saying is, look, if the values that you provide to the constructor don't meet the certain criteria that I require, then I'm going to have a fit. Right? So it's going to have a little fit, and it's going to complain. But if those values are okay, and those values are met, then we will provide those values to the object, and the object will be created. Does that make sense? Pretty straightforward. Any questions? Okay. So a point of reference that missing person is a new object of type missing person. It's using an object of type person and an object of type string, which you've all used many times already, type string. But you can create your own objects and utilize those as types. So it's a type of value. Which allows you, similar like an enum in different languages, or defining, what's it called in other languages, like defining your own sort of variable package. It's very much the same sort of thing with an object. So when we create this concept of a privacy leak. Hang on. So what does that mean? Like, now, because the object, the person object, has got mutatable values, it means that the missing person object, this is the example of the missing person object. I'll just keep tabs on time. And this is creating object person 1, and it's also creating an object person 2. And as you remember, the persons that were created have mutatable objects, so we can set the age, right? But the the missing persons object actually had a filter to make sure that certain criteria were met, right? In this example, you're creating person 1, Bo Peep, who's 5, person 2, Sean the sheep, which is 3. You're giving the location to the string location field. Then you're creating the missing person, which is providing person 1, the location, and person 2, right? So far so good. We're creating sort of a missing persons object, but we're using the objects that we've already created, which is person 1 and person 2. Person 1 and person 2 have their own sort of difficulties, and the privacy leak comes in such an example. So what would happen if I then said P1 set name to nothing? Now, if you remember, in our code, we're making the assertion, we're saying, look, you can't have get name. If you can't have an empty name. If you have an empty name, we're going to cancel the program. It's going to stop, right? But in this example, we've created that object here, and then we're saying, look, now we're using the set name and changing the name to nothing. What would happen? Any thoughts? No? So it violates our class invariant, right? So we have this condition that we stipulated we wouldn't break when we created the object, when we created the lost person. And this condition now violates it because we can do what we've just done. We've allowed the code to be manipulated without going through our filter. Does that make sense? No? Okay. Let me try and make it more clear. So we have this code, right? We have made a person. Now, when you're making objects, you try and make the smallest component of the object. And that smallest component, you give values. So, for example, we're using the smallest component being a person. That person has a name and an age, right, which is just a person, right? And then we're saying that's going to be one component of our code. That's an object called person. We'll use the object person. We'll make many objects of type person. We'll make instances of them. And then we're saying, look, we want to make a new program that looks for missing people, but we're going to be using the objects of type person and look for those people, if you will, within our new program, which is called missing persons, right? So this is our missing persons, and we're saying, look, if we have an object of missing persons, we're going to make sure that every person has a name. We can't have it that a name is empty. And also we're going to make sure that every location is filled as well. So if the location is empty, we're going to make sure that that's the case. We always will have a person on the seeker, so that whoever's looking has to have a name, and the location has to be completed, right? So this is our filter. This is our class invariance, and we're asserting that this will be the case. But then, by its very definition, this is the object missing person, and it's creating new versions of people or person. It's creating two of them in this same sort of manner. Field is just immutable, so that's just kept as a immutable object. And what we're saying is, because we've done it in this way, and because we've produced the code in this way, the invariance that we've done creates what's called a privacy leak. It means that we can then alter P1 set name because we've allowed it, right? So now we're able to manipulate the actual value. Help me if it's not making sense, throw it at me again. It now allows us to bypass that missing persons function, the filter, and change the value to something that it shouldn't be. Make sense? You sure? Okay. So it violates what's called the class invariant, right? So in this case, you've got the object which we've created by setting P1. We've actually set this value independently without going through this value. This value kind of created them. This is kind of the parent, if you will, and it's created these two sort of, I'm using these terms loosely, children, which are P1 and P2, but because of the nature in which P1 and P2 allow us to change certain values inside those, it actually allows us to change these values and therefore bypassing the code's sort of class invariance, these assertions that we're making. We're asserting that we must have a name on the seeker, and in this case it's allowing us to change the name of the seeker to nothing, right? And we need to avoid that. Make sense? Right. So it happens because the MP, missing person, sorry. It happens because the missing person shares its seeker with the person one, right? And person one has got mutators in there. Now, we need to consider this. This is a kind of an important facet of memory leaks, because most programmers don't deal with this. They don't think about this. They don't think of it as an issue. But it does become quite a big issue when you start doing programs that have more security conscious applications. Now, if you're making a video game, nobody will care. I mean, unless they want to cheat and get extra lives, you know, that's not going to cause too much of a problem. But if you're making a system that monitors an MRI machine or some hospital data, then it would be a problem, because you shouldn't be able to access the mutators in other objects. And this is why we were saying that you need to protect them by either making them private and final, or just private and giving them methods that either setters or no setters, right? So you don't have to put a setter in just because you have a value, if that makes sense. Okay, so let me just jump to, because I'm looking at the time. It's copy. So what we do what's called defensive copying, right? So in this example, it shows that if you're looking for a missing person, it's creating a person one, Bo Peepoo's 5, person 2, Sean Sheep, that's 3, and then it's changing it and saying, look, setting the name to Bad Wolf, so the Bad Wolf is looking for Sean the Sheep, and it's altering, it's changing that value on the fly. So what we do is we do this thing called defensive copying, and defensive copying is where you don't provide the pointer. This is where we're going back to the pointers. You don't provide the pointer to the actual object, and instead you provide a copy of the object. So obviously the best solution is to make the class immutable, which is what you learned, it was what you learned last week. And if you need to make those alterations, the way to do it is then to stop providing, when you provide, if you go to the person, instead of returning, get first name or get name here, instead of returning this, what you do instead is you return a new object of this. So you create a new object with the same values and return that value. And that enables or enforces the concept that you cannot alter the original person, because you're giving a copy of that person rather than the location to its memory, if that makes sense. Let me show you with the slides. Generally we put these copy new versions of the objects inside the constructors or the getters or the setters. That's what we do, and we do that by simply, instead of providing a person with an age, and like we did with this example, we provided the first name and the last name and the age. Instead, we provide a new person. Oh my gosh. We provide a new person called the original, and then we create the instance of that object. It does seem a little complicated, but it makes sense. When you're creating a new person, you tell it that you're creating a new person, you give it a person, so you can provide a person to that object because it's an object, and then you take the name or the original value of that name, and the name, and you provide that as the object's name. So essentially what you're doing is making a copy, an exact copy of the inputs, and that then becomes the object that you use. And by doing so, you never provide the pointer to the actual object, and instead you're giving a new, fresh version of the object when you're creating it. Does that make sense? I see a lot of confused faces. So to construct that, so instead of, like in the previous slide, this is the person object now. It takes in a person, right? And as you know, a person has certain values. And then that missing person creates a new person. So when it's creating a seeker, it makes a new person of that missing person to create it. Obviously, the location is immutable. And by doing so, you're essentially duplicating the actual persons instead of making or passing copies. I'm sure that's not making much sense. So here, when we create a new person, we're making this is creating a new missing person. We're populating these values, right? But instead of just taking the person here, seeker, and the location and the person, we create a new object of those. And that new object here, so we make a new object, but taking the original values of those as the parameters for that creation, and that ensures that the copy that we have as the missing person has no ties and no reference to the original value. Does that make sense? Okay. So essentially, this is what we're doing. So the missing person is basically, rather than sort of pointing at the original values, which it was doing previously, it now creates new versions of those values. And if you change these values, it doesn't affect if you change these values, the P1 and the P2, it makes no difference to the values that we have stored, because essentially we're not giving a connection to those. I hope that makes sense. I see a lot of confused faces. Okay. Anyway, just understand that the way to, I've got looking at the time, I'm just very aware of it. Essentially what we're doing is we're saying, look, when you make a new object, instead of making just a new object and providing the parameters for that object, instead provide a new version of that object for the object you're creating. Yeah, that doesn't make sense, does it? It does make sense. Yes? It is. It is. So that's a very good question. So it solves it by, if you look at this example here, or this kind of depiction of what's happening compared to, so if I go back to this depiction here, the original method would be to create this, to create new objects within the actual missing persons class directly, creating new people and new persons. And those new persons, because they call P1 and P2, it enables you to call upon those variables and alter values that are mutable within them, right? But by creating this sort of condition, where we're creating, instead of just simply creating new people, a new object, and supplying that object as the actual new person that you're creating, you take the values of the new object that you created and make a copy of it and send the copy. So that copy doesn't have a local variable. It doesn't have P1 or P2. It simply provides the values of those objects by kind of not aliasing, but making a deep copy of them. No, you don't have the hooks then, so you can't actually connect to those directly because you can't access P1 and P2. So I think, let's see, so you have this example here. So you have a missing person, you have the same parameters here, but instead of the previous way of just making a new person, instead of just making a standard new person and providing that as the parameter, you actually make a new instance of the person using the parameters of the new person. What you're trying to do is separate the pointers, which is why we're referring to the pointers at the beginning. And this is like a big deal within Java, in the sense that it's stopping leaking of information, so that you can't manipulate the information without realizing. So the key is that every time that you provide, so for example, I'll try and make an example here. If you have an example of person, if you want to get the first name, instead of providing this first name, what you would do is you would make a new instance of the object and provide, of the name, should I say. So here, instead of doing this, you would say, this would become a person. Actually, I will do that. This will become a person, and then you provide a new person, and then you give those values. I hope this makes more sense as an example. Like that. So rather than just returning the value, which you can manipulate, you return a new object that contains the values. Does that make more sense? Yep. Right. It's It does so by not allowing you to have access to the original pointer. So you can't, if you change the local copy, it doesn't affect the original. So the original value remains, and then the local copy, it gets damaged, but the actual original is still maintained. Yeah. Make sense? Okay. Okay, so as a quick, I'll tell you what, let's just do, so I asked for 3 volunteers, right? So I'm going to ask 3 volunteers to come to the front, and we'll just do a quick sort of memory issue. Yeah, let me put the lights on. Right, I'm going to ask for, sorry, everyone's retinas are just bent. I want 3 volunteers, don't be shy, anyone, just come to the front. It's not going to hurt, I promise. And I can see you're all shy now. Shall I start pointing? Who's going to be brave? Come on. You're going to simply hold some paper, and I'm going to talk, and then you're going to do whatever it says on the paper. It's not acting. You don't have to be a chicken or a dinosaur, nothing like that. Come to the front. Come on. There's one. And we need 2 more. Thank you. Thank you. And 1 more. Right, so if I give you that one, if I give you that one, I need 1 more. Thank you. Brilliant. Hold those. So if you read those quite carefully. Now then, so we're essentially showing the difference between the original method of having, utilizing the object and changing upon the object. And then we've got, I'll show you what the deal is. So, number 1. Have you read it? You don't have to read it out. Okay, can I have that piece of paper? So this paper represents an assignment that they've all been working on for 3 months. And it really is important. It's so important. But I would like to have a look at this paper. There you go. Thank you for that. So he just gave me his values, and I was able to manipulate them. Now, you're number 2?
Yeah.
Could I have yours?
Yeah.
Oh, no, have you read it?
Have finished it?
No.
Okay.
So I'm going to ask, can I have it? And you're going to, aha. So he's showing me it, but he's not giving me the value, right? So this is immutable. So I'm allowed to see it, but not change it. Whereas you were mutable, so I was able to just destroy it, right? And may I have your copy, please? So he's made a copy. And he's given me a copy, so when I rip this up and alter it, he's absolutely fine. Does that make sense? Okay. Thank you, guys. Thank you. A round of applause, guys. Thank you. Thank you. Okay, so hopefully that kind of give you a depiction of what we're talking about. I thought about that forever. Any questions on that? There you go, so I can see you guys a bit better. Okay, so by doing this, by making a copy, it enables you to provide the values to a calling object. And that calling object can alter those values, but it doesn't change the original values, so the original values are always available. Another way, and the correct way of coding, is to keep everything immutable, so that the second version of what we just showed, it just shows the values, so they can't be changed. But if you do need to change them, never give the values directly. Instead, provide a copy of those values so that they can be manipulated without damaging the original. I hope that kind of makes some kind of sense. So in summary, if you don't define your variables as final, then you're allowing them to be modified by any value that has access to them. Public methods modify instant variables, which makes the class mutable, so you can change it. We tend to use mutable classes all the time. If you're the only one that's going to be using your code, what does it matter, right? You're the only one utilizing it, therefore it won't make any difference. Make all your classes mutable, make them all public. It doesn't really matter, the code doesn't care. But when you're doing something for a company, then you need to consider the protection of the data and the values therein and how they're transmitted. And you've got to protect them. And the best way to protect them is to make them immutable first. If you can't make them immutable, if they need to be changed, then the second way is to actually produce a copy of that value when you're returning values, either through the constructor, through the getters, or through the setters. And that enables you to sort of at least protect the original values so that they're not destroyed or manipulated as they're being passed around. Privacy leaks are a big deal. Often, I don't know, I was reading only this morning about Apple. For the last 2 years, they've been seriously hacked on all the phones, and all the values have been taken in. And it's not, I'm not saying it's a privacy leak like this, but it certainly is something that people have manipulated using very advanced methods, but the concept is the similar sort of thing. If you allow a door open for values to be changed, read or altered, then somebody will find a way in and will do that. And the solution obviously is to keep a copy of, to provide mutable copies to calling objects, so that if an object if another object is calling your object or making a version that wants to use your object, or some object, it's best to make a copy of it. It's not a common thing to do because it does use more memory, but for the purpose of understanding memory leaks and understanding the importance of protecting data, this is something you need to consider. Now, any questions before we call it a day? No? Okay, guys, we shall call it there, and we'll see you guys next week. That's okay.